Okay, guys, this is the part 2 of the examples from your work, energy, and power guided notes. So here we go. We're going to talk about potential energy. So with potential energy, there are two different types of potential energy. These first two examples are going to be potential energy of elastic potential energy, and the last one will be gravitational potential energy. So the formula for elastic potential energy is PE of elastic is equal to 1/2 K, which K is a spring constant, and that'll be given to you in the problem, times your distance compressed or stretched squared. So it says a spring with a force constant of 5.2 newtons per meter has a relaxed length of 2.45 meters when the mass is attached to the end of the spring and is allowed to come to rest. The vertical length of the spring is 3.57 meters. Calculate the elastic potential energy. So in order to do that, we are going to start plugging stuff in. So we know it's 1/2 our, oh my goodness, what was that? Our K value is that 5.2 newtons per meter. And then to get that V value, or sorry, that should be X, not V. That X value, we're going to subtract 3.57 meters minus 2.45 meters. And then we're going to square that. So it doesn't actually matter what order you put it in, because if it ends up negative when you square it, it will be positive. So you plug those numbers in. Again, make sure you square it. Make sure you multiply by 1/2 at the beginning. Remember, you can also do 0.5 in your calculator if that's easier for you. And you'll get an answer of 3.26 joules. All right. Next one is the exact same type of problem. So potential energy elastic is equal to 1/2 kx squared. It says the staples inside of stapler are kept in place by a spring with a relaxed length of 0.115 meters. The spring constant is 51 newtons per meter. How much elastic potential energy is stored in the spring when its length is 0.1150 meters? So PE elastic is going to be equal to 1/2 our spring constant of 51 newtons per meter. And then we're going to multiply that by your X value, which we're going to do 0.150 meters minus 0.115 meters. And you're going to square that again. And you should get 0.031 joules. All right, next one. This is going to be gravitational potential energy, which gravitational potential energy, oh, my E looks weird. That's okay. Is equal to our mass times gravity times height. And remember, gravity is going to be 9.8 meters per second. It says a 40 kilogram child is on a swing that is attached to ropes 2 meters long. Find the gravitational potential energy associated with the child. So your mass is 40 kilograms times your value for gravity, which is 9.8 meters per second, times the height of 2 meters. And you should get 784 joules. All right, let's talk about conservation of mechanical energy. So conservation of mechanical energy tells us that your mechanical energy value is equal to your kinetic energy values plus the sum of your potential energy values. That could be gravitational, elastic potential energy, any potential energy you have. So the really fun and exciting formula for this is 1/2 mass times velocity squared of initial velocity plus m times g times h. So this is initial kinetic energy plus initial potential energy is equal to 1/2 mass times velocity squared of your final velocity. So your final kinetic energy value plus your final potential energy value. So lots and lots of numbers. Most of the time you get lucky though that one of these kinetic energy is a velocity of 0, so you don't even have to calculate that part. So let's just go for it and see what happens. A bird is flying with a speed of 18 meters per second over water when it accidentally drops a 2 kilogram fish. If the altitude of the bird is 5.4 meters and the friction is disregarded, what is the speed of the fish when it hits the water? So we're solving for final velocity or final speed. So we're gonna just start plugging in numbers. So let's do this. Lots of numbers to plug in. So I'll try to use lots of colors. So we're gonna do the initial kinetic energy. So 1/2. We know the mass of the fish is 2 kilograms. And we're told that it's moving with a velocity of 18 meters per second. Plus your initial potential energy, which again is also 2 kilograms, times your gravity of 9.8 meters per second, times your initial height of 5.4 meters. And then this is all going to be equal to your final values, which I'm going to do in green. We are solving for velocity final, so that's 1/2 times 2 kilograms times v squared f plus your mass of 2 kilograms times, again, gravity of 9.8 meters per second. But your height final is going to be 0 meters. Let me put that. Your height final is going to be 0 meters. So this whole value here is going to cancel because anything you multiply by 0 is going to be 0. So really what we're solving for is equal to 1/2 2 kilograms of your velocity. Oh my goodness. Of your velocity squared final. So I'm going to erase all of this really quick. All right, I'm going to cancel out some stuff for you real quick. All right, I did calculate these values individually. So this first value here equals 325 joules. Plus this value here is equal to 105.84 joules. And that's going to be equal to, when you do 2 times 1/2, you get 1 kilogram times your velocity squared final. So we divide both sides by 1 kilogram, divide that by 1 kilogram. You add these two numbers together and you'll get 430.84 joules. So I have left V squared final is equal to 430.84 joules. And I'm going to square root that because your V is squared. So your velocity final is equal to 20.7 meters per second. So big honking problem to get that. So you really just have to make sure you're plugging in everything correctly and work slow, and that's okay. Let's do the next one. I have not pre-worked out this problem, so it's going to be fun. It says a 755 Newton diver drops from a board 10 meters above the water's surface. Find the diver's speed 5 meters above the water surface, then find the diver's speed just before striking the water. So we're going to do the same thing we did previously, only we're going to calculate it once, where 5 meters is your final height, and we're going to do it a second time where 0 meters is your final height, because we want to calculate the speed. So I'm going to just rewrite that formula out really quick. Let me pause this and I'll come back to you. Like magic, that formula is up at the top now. So let's start plugging in numbers. I'm actually going to plug these in separately, and then I'll talk you through it. So hold on just a second. Okay, so if you notice, the divers, we're given his weight in newtons and not his mass in kilograms. And we know that force equals mass times acceleration. So from there, we can solve for how many, what his kilograms are. So no, force is 755 newtons. My fives are not working. Is equal to his mass, which is what we're solving for, times his acceleration of 9.8 meters per second. So you divide both sides by 9.8 meters per second. 9.8 meters per second. You're going to get his mass to be equal to, what is his mass? 77 kilograms. Oh, 77 kilograms. I must be holding my stylus weird. Okay, hold up, and I'll have some work for you. All right, I've plugged things into the formula. Since we're starting where he's just dropping directly in the water, he doesn't have a speed or velocity in the beginning. So this value actually cancels because it's 0 for your velocity. And then we have his potential energy to begin with because he's not moving in the beginning, so he doesn't have any kinetic energy. He just has potential energy. So 77, which is his mass, times gravity, times your height because you're starting 10 meters above the water. And that's going to be equal to your final kinetic energy. So we are solving for this value here. And then 77 times gravity, which is mass times the gravity, times the 5 meters, which is the distance above the water surface to begin with. So let me rearrange this for you. All right, so being fully rearranged, and I do know these values here, so we know that this value here is equal to 7,500. Oh my goodness. I have like a weird dead spot on my screen. 7,546 joules. Okay, that's a 4, I'm sorry. Which is equal to 38. Oh my, what is happening? 38.5 kilograms times your velocity final squared. Plus this value here, which is 3,773 joules. So you're going to subtract 377 joules from this value here, which is going to equal, I didn't work that out. And then you're going to divide by this value here. So you'll end up with the final formula. Let me put it up here for you. Okay, so when you do all that, this is what you end up for your final formula up here. And then you're going to square root both sides. And you should get your final value for the 5 meters to be 9.89. 89 meters per second. Oh my goodness, why won't it right? I think my wrist is hitting it. Meters per second. Okay, so do the same thing for the second one, only this time you're going to plug in, instead of 5 meters at the end, you're going to have 0 meters. So I'm going to put that formula down real quick and show you how to get the final answer. So give me just a second. Okay, let me tell you how I got here. So I plugged everything in like we did in the last problem, except now this first part has an initial velocity of 0, so that's not worth anything. And since it's just above the water surface, this isn't worth anything because that's 0 meters as well. So down here are the values you get when you plug everything in, and then you're going to divide both sides by 38.5 kilograms. And then what you're left with is V final, so you're going to square root that, and that should give you a final answer of your V final being, you plug all that in, you end up with 14 meters per second. That is an M. You can't tell it's an M. All right, I'll see you guys later. I think there is one more set of examples for this assignment when we talk about power, but those are much easier. All right, bye.